Cracked screens once meant guesswork. AI now diagnoses in seconds. Back in the day, you'd hand your phone to a tech who'd squint at the glass, tap a few spots, and hope the damage didn't run deeper than it looked. One wrong guess, and you'd be ordering parts twice. Today, that entire process is flipping into data. AI systems scan the screen, map every fracture, and tell the repair shop exactly which layer is broken before a single screw comes out. But how does it actually pull that off in real time? Stick around, because the answer changes everything about how we fix phones. First, let's remember what the old workflow really cost us. A technician would start with a visual check, then maybe run a basic touch test. If the display still lit up, they might assume the digitizer was fine. Miss a hairline crack under the OLED, and the whole panel fails 2 days later. Shops ate the cost, or customers got angry. Either way, time and money leaked out. Now picture walking in with the same phone and an AI app lighting up the screen in under 10 seconds. It doesn't just see cracks. It measures pixel response, backlight uniformity, and even microdelamination invisible to the eye. The model was trained on millions of repair photos and sensor logs, so it knows the difference between a surface scratch and a pressure fracture that will spread. That single scan spits out a parts list and a repair time estimate with 90+% accuracy. Open question though. What happens when the same AI starts predicting failures before they happen? We'll circle back to that in a minute. The real magic sits in the computer vision stack. A phone camera or a bench-mounted rig captures high-res images under controlled lighting. Convolutional networks break the image into layers, flag anomalies, and cross-reference them against a live database of known failure modes. Some shops are already piping that data straight into their inventory system, so the right OLED ships before you even sit down. Accuracy keeps climbing because every completed repair feeds new labeled images back into the model. It's a flywheel that gets smarter with every cracked device that walks through the door. Still, the tech isn't magic. Lighting conditions, screen protectors, and certain aftermarket glass can trip the algorithm. That's why the best systems combine AI output with a quick human sanity check instead of replacing the tech entirely. The payoff shows up in speed and cost. Average diagnosis time drops from 15 minutes to under 30 seconds. Wrong part orders fall by roughly 70%. Customers leave with a transparent quote instead of a surprise bill. And because the model learns from every job, rural shops with less experienced staff suddenly perform like flagship service centers. Remember,